All right, let's talk about const and static. Const and static are basically two keywords that kind of apply properties to variables or functions. Starting off with constant, constant is a keyword that lets the compiler know that something is immutable. And what the word immutable means is that it's not able to be changed. So someone can't come in and reassign it, you can't increment it. Basically, anything that changes a variable can't be done to a constant. So I have a class called triangle here, and it's basically very simple. We have a private data field with base and height. Then we have two constructors, one with no argument that defaults the triangle to base one and height one. Then we have a constructor with arguments that allows the user to pass in a base and a height. And then we have a getter function for the base and a getter function for a height. And then we have a function here that computes the area of the triangle. So let's just use this class in action so you guys are all caught up. So let's create a triangle T1, and then we'll see out T1 dot get base. And we'll do T1 dot get height. And then we'll do T1 dot get area. So what this basically do is just show you guys like all the functions in action, just so you're all caught up and there's no confusion about what's going on in this class. But it's basically just a simple triangle class that allows us to get the area. Triangle has no member get height. I have a typo here. There we go. And then let me put a space in between that too as well. Okay, so this should print out, because T1 defaults to 1, 1 for base and height. This should print out 1, 1, and then 1 times 1 divided by 2, which is the formula for getting the area of a triangle. 1 times 1 divided by 2 is just 0.5. So this should be 1, 1, 0.5. 1, 1, 0.5. Okay, so now you know how the triangle class that I created here works. So what about constant? What does constant do for our class here? Well, let's look at our two getter functions, get base and get height. All these are doing are returning the base and height of our triangle, and that's all I ever want them to do, because they're getter functions that allow us to access these private data fields. And the reason why we made these private in the first place is that no one can come in and say, haha, t1 dot base t1.base is equal to like 300. And the reason why the compiler would scream at us for doing this is because base is inaccessible, aka it's private. But because we didn't put constant in front of our getter function, we can actually circumvent that whole immutability by just going to base and then setting base equal to 300 here. And if we run this code, well, then that's going to mess up our triangle that we created immensely. See here, before it was 101 0.5, now it's 301 and 150. But we didn't create a triangle with those parameters. We just wanted a triangle with 1 1. So how do we how do we get rid of this circumvention? Well, we put in the constant keyword in front of our function declaration right before the curly brackets. This allows it so that whenever someone comes in and tries to set the base to a new value, we're going to get an error here. And actually, the compiler won't even run. See here, we got an error. So that's basically what constant does. It basically makes it so that whatever variable that's used inside of the function is immutable, aka meaning that no one can come in and change it. And you mostly want to use these for getter functions, because getter functions are supposed to be read-only functions, meaning that they're just there for you to see it, not for you to write on top of it. So if we run this code again with our new constant, we're back to normal at 110.5. So now we got constant out the way. That's pretty simple. Let's talk about static. Now, static actually depends on the context. You can actually have static variables or static functions, but let's focus on static variables for a second. So static variables are variables that retain their value between function calls. And what that basically means is that whenever you have a function and you pass a value through it, that variable actually resets once the function is done with it. So I'm going to delete everything in main here because we're not talking about the class right now. Let's just create a function outside of the triangle class called count that basically increments a variable by 1. So we'll do void count, and then we'll create a for loop. We'll do int I set to 0, and then we'll do I is less than 11 for 0 to 10. And then we'll just print out I. So we'll see out I, and then let's just put a space in between. So basically all this program does is it counts from 0 to 10. So we will see out, we don't have to see out, we'll just call the function. So call the function count. And yeah, that works just about as we expect. This counts from 0 to 10. But what if we call this count function multiple times, right? So we'll do count, 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 count. So we call the count function 4 times. And just for readability, I'm going to see out in line after this because we don't want all those numbers in one line. So we'll create a new line after the count is done. So we call the count function 4 times. What do you think is going to happen? We're just going to get a count from 0 to 10 4 times, right? Yeah, cool. That's just about what we expect. There's nothing new here. But what if I put static in front of this I here, this integer I? I put static in I. How is that going to change my function at all? Try to guess. Remember, static variables retain their value between function calls. So can you take a guess as to what's going to happen when I run this code here, now that the integer here is static? Let's run it and see what happens. Okay, so we got a count of 0 to 10, but we only did it one time. What gives? Well, that's because, remember, our stopping condition is I is less than 11, right? And we just keep going. We keep incrementing I as long as it's less than 11. So let's think about what happened here. Let's break it down line by line. So when we called count here, right, it ran this code and I went through the for loop, right? So I incremented by, so we did I was set equal to 0, and then it was 1, and then it was 2, and then it was 3, and then it was 4, and then it was 5, and then it was 6, and then it was 7, and then it was 8, and then it was 9, and then it was 10. But once it hit 11, there's no more for loop because we want to keep going until I is less than 11. So once I hit 11, then there was no more outing the I. So why did making static only create one count to 10? Well, because this integer I here, now that it's static, it'll retain its value between the function calls. So when we went to the second function call, instead of I being set back to 0, like inside of this line here, instead of I being set back to 0, it actually started off as I is equal to 11. And remember here, if I is if I is less than 11, then we keep going. But in this case, I is no longer less than 11. So this line did not execute because this condition right here in the middle was not met. Now I realize that might have been the most ambiguous way to represent it. So I'm going to modify this code a little bit so that you guys can actually visualize. So let's change this back to normal. So now we're back in the world that you all know and love. And this prints out 0 to 10 4 times, right? Let's create a variable, an integer variable called n. And we'll set that equal to 0. So now this still does everything as normal, but now we just have a new integer here called n. So now it says for I, 0 to 10, increment by 1, see out the count, blah, 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 blah. And then at the end, we will create a new line, but I want to add something here. Let's do n++ at the end. And instead of see outing just a new line, we will see out n and then a new line. And let's see what happens. So we call count 4 times and let's run this. Okay, so now we have a count of 0 to 10 and then we see out 1. Why? Why is n now 1? Well, because we initialized it to 0 and then we did +1. Well, we did an increment of like 1. So that's cool. That runs as expected. What if we made this integer static? Now that this integer is static, this increment will carry over between function calls. So in this first function call, n is now 1, but in this second function call, because n++, it'll be now 2. And so on and so forth. So let's run this code and see what happens. And yeah, so we ran through the for loop and did n++. Now n is 1, so we print out n. We ran through this function call again, did n++. N still is 1 because it is as a static integer. and then we did plus plus, which makes it 2, print it out, and so on and so forth. So that's what the static does. It allows the variable to retain its value between function calls, because normally values do not retain their value. They're just reset every time you call the function. In this case, it was reset to 0, incremented, printed out to 1. So let's talk about static in the context of functions, because they're a little bit different inside of functions and classes. So let's go back to our triangle function here. Remember, we had a function called double get area here that returns the area of the triangle based on the object that we created. We can actually create this into a static function and basically use the same logic for variables that we want to pass in. So what do I mean by that? So let's say like, hey, this get area function is actually pretty useful. I want to use it without being able to create an object. So in order to do that, we just put static in front of double. And what this basically does is this function now belongs to a class, but it can be called without using an object. And if you remember what I said earlier, if we wanted to go in here and say, hey, get area, we would get squiggly lines because it's going to tell us get area is undefined, because we have to have an object in front of here, for example, like T1 or T2 or just whatever object that we create. But now that we created a static version of this function here, instead of passing in base and height, which belong to the class, we pass in our own variables like double B, double H. And then we got to change these respectively. So now instead of getting the area for an object, we just get an area for 2 values that we pass in. So we can go into our main here, and this is how we call the function. We do the class name, because this function still kind of technically belongs to the triangle class. So we call the class name dot get area, and then we pass in the values we want. So let's just say this isn't an object. This is just a triangle that we want to get the area for. Let's say we have a triangle with a base of 4 and a height of 6. We wanted to get the area of that. Well, we could just call this static function here. And that allows us to get the area of a triangle without a class. Without an object. So we run this, and this cout's. We didn't do the cout. That's my bad. We have to cout the function here, and then we get 4 times 6 divided by 2, which is the area of the triangle with 4 and 6 as base and height respectively. So that's what static allows us to do. It basically allows us to create what we call utility functions that basically have the same logic as maybe another class function, but we want to use it for values that are not particularly like instantiated inside of an object.